Hello, welcome viewers to this virtual channel. In today's lesson, I'll be talking to you of probability scale and probability of single events. Probability scale. Let's talk about what probability is first before we talk about the scale. Probability is used to describe the chance of an event happening, and a typical scale is from 0 to 1. Now, in real life, certain events are bound to happen. They are certain to happen. For example, a day after Monday is Tuesday. It's certain events because a day after Monday will always be Tuesday. Such events will have probability equal to 1. Then we have events that are impossible to happen. For example, in our normal base 10 counting, 2 being an odd number is impossible. So such events will have probability equal to 0. Then we also have events that are either or. We call them, they have a chance. For example, a baby born will either be a boy or a girl. So this kind of events, we call them events. And they have half a chance. Probability of such events will be equal to a half. Then that leaves us to events that have small chance, but it's not impossible. An event that have bigger chance, but it's not certain. So such events, we call them unlikely when they have a small chance or less likely. And when events have big chance, we call them likely or more likely. So likely means bigger chance but not certain. Unlikely means less chance but it's not impossible. We'll have an example to explain this as we go along. Now, how do we calculate probability of events? 5 sections divided in spread divided into 5 sections, 1, 2, 2, 2, and 3 written on the sections. The chance that falls on 1, 2, 1 or 3, or an odd number is what you're supposed to work out. The chance that falls on 1 is 1 out of 5 because there's only one section with number 1. Falling on or stopping on 2 is 3 sections, so it's 3 possible ways, 3 out of 5. 1 or 3 is 2 out of 5. Then an odd number, 1 and 3 are odd number. These 1 and 3 are odd numbers, so that's 2 over 5. So this is how you calculate simple events. Now, what about working out events and putting them on a number line, probability scale? So we have 12 cards. A card will either have A, E, or U on it. We're supposed to work out probability of A, E, and U and place the event on a scale. The scale given to us has 6 sections, so each answer that we have, we can rewrite it in equivalent way to make it out of 6. So we label our scale. P of A, there's only 2 cards with A, so 2 over 12, which is 1 over 6. So we put P of A on the scale. P of E, 6 cards flashing, so that's 6 over 12. 6 over 12 is 1 half, or 3 over 6. So we put P of E on 3 over 6 or half. P of U, 4 cards flashing, 4 over 12 or 2 over 6. So this is how we put events on a scale. And you can be asked to describe it. If you are asked to describe it, P of E is events. P of A and P of U are all unlikely events, but A is less likely. P of A is less likely. Now let's look at rolling a die. Chance of getting a 6. On a die, there's only one face with a 6, so that will be 1 out of 6. An odd number, we have 1, 3, and 5. 3 odd numbers, so that will be 3 out of 6. More than 2. 1, 2, 3, 4. 4 numbers, so 4 out of 6. And 8, there's no 8 on a die, so that is 0. A number less than 7 is 1. Now be careful. When you are asked to work out probability, they want the numbers, the answers like this. Don't start saying unlikely or impossible or even. Those are only for description. So working on probability, work out the real numbers. To put the events on the scale, they are out of 6. So you put a probability scale divided into 6 sections. You can now put the events on the scale accordingly. As you can see. And that is done. Now you can be asked to describe it. So event I is unlikely. I events. I likely. Impossible. Certain. So you now understand why we call this event unlikely, because it's between impossible and events. And we call this likely because it's between events and certain. Now when it comes to deck of cards, students get confused because they don't seem to understand the composition of deck of cards. Now for you to understand, a deck of cards, we have 13 cards of spades, 13 of them from ace to the king. Then we have 13 cards for clubs, 13 for hearts, and 13 for diamonds, totaling 52. So when you say 52, we mean this composition. So to get 2 of spades, if you come to the spades, there are only one section, one card. So that's 1 out of the possible 52. That's 1 out of 52. A jack, J is jack, Q is queen, K is king. A jack, they didn't specify the color, so we have jack in each of the suits. So there are 4. That will be 4 over 52. You don't need to normally simplify probability. So just leave it like that unless otherwise stated. King of red card. So these are the king of red cards, 2 over 52. A card of diamonds. You go to the diamonds. There are 13 of them. So 13 over 52. A king or a queen. They didn't specify. A king or a queen. So that will be 8 of them. An ace black card. These are the ace. We want the black card, which is also an ace. So that will be 2 out of 52. Now, when we say face card, these are the pictures. The picture cards are the face cards. So a black face card, we have 3 here, 3 here. These are red. We don't count them. So that will be 6 of them. 6. Then a black card, 26 of them. 26 of 52. The non-face card, that means cards without pictures. You count all of them, and that will be 40, 52. So that's, once you understand the composition of the cards, you will really be able to answer questions on deck of cards. Now let's look at probability after change of sample size. Michael has a box of pencils. The box contains 6 blue pencils, 8 green pencils, and 3 red pencils. Some more blue pencils are added to the box. Probability of selecting a blue pencil is now a half. How many blue pencils were added to the box? Now you need to take time to really read the question to understand. So let's look at the pencils we had before. Okay, so this is what we had before, right? Now, if we are saying that we're going to add more blue pencils, and after adding more blue pencils, probability of a blue is going to be half, which means that probability of a green and red must also be half, because they all together should be equal to 1. So it means the blue pencils represent a half. The blue pencils represent a half, and the other one will also represent a half, like I said before. So green and a red represent a half. Now, how many greens and how many red do we have? We have 11. So we are saying that for you to have probability equal to a half, that equals to 11 pencils, then the rest should also equal 11 pencils. This represents a half, and that equals 11. Half represents 11. Then the blue must also be 11. But how many blues do we have here? We have only 6. So 6 is from 11, and that will be 5. And if you count everything now, we have 11 pencils. and this is also 11 pencils. And it makes sense that if this is half, then the whole thing here must also be half. Let's look at another example. This time, we have 6 blue pencils, green 8, red 3. We're going to add more red pencils, and probability of selecting a red will be a third. How many red pencils were added to the box? Okay, so we start. Red pencils represent a third. That is after we've added the pencils, more red pencils, the number of red pencils that we'll have will represent a third. That means the blue and green represent 2/3. Blue and green represent 2/3. So 6 plus 8, which is blue and green, is 14. And 14 is 2/3. Now ask yourself, if 2/3 represent 14, then you know that a third is a 7. Because 2/3 is 2 lots of a third. So 1/3 will have to be 7. So if you know that red must now be 7, but you now have 3, to work out how many more you need to add, you need to take away 3 from 7, and that will mean we need to add 4 more red pencils. So that means 4 more red pencils were added for probability of red to be a third. And it makes sense. If 7 represents a third, then 14 represents 2/3. And that brings us to the end of lesson 1. Look out for lesson 2 for relative frequency and experimental probability. Thank you very much for watching. Please subscribe, share with your friends. Thank you very much.